October 1941. A strange trio. A typewriter manufacturer, a jukebox company, and a man once imprisoned for murder are racing against time to equip 6 million American soldiers with a brand new weapon. What emerges almost feels impossible. The M1 carbine was never supposed to exist. It was pieced together from unlikely origins: a Winchester hunting rifle experiment, a reworked Garand operating rod, and a gas piston system invented by someone who learned gunsmithing behind prison walls after killing another man. The U.S. Army handed Winchester a near-impossible challenge with only weeks to spare. Build a rifle that weighed half as much as the M1 Garand, fired faster than a bolt-action, and cost less than a handgun. What they produced was a rough prototype assembled from spare components, one that nearly failed inspection just hours before the deadline. That crude, hastily built firearm would go on to become one of America's most important wartime weapons. By 1945, it would surpass every other firearm in U.S. military history in production numbers. To understand why it mattered, go back to June 1940. France collapses in just 6 weeks. German panzer divisions tear through the Ardennes, smashing Allied defenses with shocking speed. American military observers watch the footage and grasp a terrifying reality. Warfare has fundamentally changed. Blitzkrieg doesn't spare non-combat troops. Advances happen so fast that radio operators, truck drivers, mortar teams, and supply personnel are suddenly under fire before infantry units can even react. Most of these men carry M1911 pistols, 7 rounds, effective at perhaps 50 feet. When German reconnaissance units appear hundreds of yards away, those pistols are useless. The Thompson submachine gun is available, but it weighs around 10 pounds and costs $225 per unit. The M1 Garand is an outstanding rifle, but at nearly 10 pounds, it's exhausting for anyone already burdened with heavy equipment. Picture a young American supply sergeant in North Africa, perhaps a Signal Corps wireman. He's carrying 50 pounds of radio gear. Add a 10-pound Garand slung over his shoulder. He's been marching for 8 hours. His shoulders burn. The rifle snags on his pack straps, tips his helmet over his eyes when he bends down. When contact is made, he's slow to bring the weapon into action. The Garand is perfect for frontline infantry. For everyone else, it's dead weight. Army leadership takes notice. In 1938, the Chief of Infantry asks the Ordnance Department to develop a lightweight rifle, something compact, effective, and practical for soldiers who aren't traditional riflemen. The requirements are strict. The weapon must weigh no more than 5 pounds. It has to be effective out to 300 yards. It must fire semi-automatically, and it needs a brand new .30 caliber cartridge. The official approval doesn't come until 1940. By then, time is already running out. America is heading toward war, and they need a solution immediately. Enter the Winchester Repeating Arms Company, a legendary name in firearms, already overwhelmed with contracts. They're producing M1 Garands for the Army, alongside commercial hunting rifles. When the carbine requirement is announced, Winchester doesn't even submit a design at first. They're overloaded, understaffed, and stretched to the limit. But Edwin Pugsley, a supervisor at Winchester, sees a chance. His team has been working on a hunting rifle built around a .30-06 cartridge. What if they scaled it down, shrunk the action, adapted it to the lighter .30 caliber carbine round, simplified the gas system? It sounds insane. It might be impossible. And they don't have months, they have weeks. Pugsley assembles a small team: William C. Romer, Fred Humiston, and 3 other engineers whose names history barely remembers, but whose work will arm millions. They work non-stop, fueled by coffee, cigarettes, and pure urgency. The deadline looms. In May 1941, the first prototypes from competing companies, Colt, Garand, and independent designers, fail Army testing. A second round of trials is scheduled for September. Winchester now has 4 months to build something out of nothing.
And then there's David Marshall Williams, a convicted murderer who killed a man during a shootout with revenue agents in North Carolina in 1921. In prison, a warden recognizes his obsessive mechanical brilliance. Williams is allowed to set up a workshop. He designs firearms, files patents, and invents a revolutionary short-stroke gas piston system, one that will reshape weapons design forever. After his release, Williams joins Winchester. His gas piston becomes the core of the carbine. But he's difficult, working separately from Pugsley's team, focused on his own designs. His system won't be ready until December 1941, 2 months after the Army needs submissions. So Pugsley's team moves forward without it. In just 13 days, 13, they assemble the first prototype. They strip parts from a Winchester M1905 for the trigger housing. They rework a Garand operating rod. Piece by piece, under impossible pressure, the rifle begins to take shape.
The engineers hand-fit parts that were never meant to be fitted by hand. Precision machining is replaced with improvisation. The prototype becomes a mechanical patchwork held together by creativity and sheer luck. Then, just hours before submission, disaster strikes. The gas port is undersized. The rifle cycles slowly, flirting with constant jams. One engineer doesn't hesitate. He grabs a drill and enlarges the gas port by hand. They test-fire the rifle again. It runs, just barely. There's no time left. The prototype is sealed in a crate and rushed to Aberdeen Proving Ground. September 1941, Aberdeen Proving Ground, Maryland. Army evaluators arrange the competing carbine submissions side by side. Winchester's entry looks rough, because it is. The others appear refined, polished, and professionally finished. Winchester's rifle is a last-minute creation, assembled from borrowed components and emergency fixes. Testing begins. Accuracy, endurance, drop tests, mud trials. The Winchester carbine doesn't just pass, it excels. It comes in lighter than the requirement, at roughly 5.5 pounds. It cycles dependably. The short-stroke gas piston keeps fouling to a minimum, tapping the operating rod just enough to unlock the bolt before venting excess gas. There's no long piston dragging debris through the action. The rifle stays cleaner for longer periods. Recoil is mild, the firing rhythm controllable, follow-up shots easy to manage. On October 22, 1941, the U.S. Army officially adopts the design as the U.S. Carbine Caliber 30 M1. 2 months later, Japan attacks Pearl Harbor. The United States is suddenly at war, and the carbine that nearly failed to exist becomes absolutely critical. Production begins immediately, then reality sets in. Winchester alone can't supply what the Army needs. Carbines are required in the millions. So the Army turns to unexpected partners, not firearms manufacturers, but industrial giants. General Motors Inland Division, accustomed to automotive parts. IBM, famous for office machines and punch card systems. Underwood, a typewriter maker. Rockola, the jukebox company. Saginaw Steering Gear, Standard Products. Hardware manufacturers with no firearms background are handed blueprints and told to start building rifles.
This is where the brilliance of the M1 carbine truly shows. It was engineered for mass production. Parts are fully interchangeable across factories. You could take components from an IBM carbine, a Winchester carbine, and a Rockola carbine, mix them together, and assemble fully functional weapons. The tolerances are forgiving, the design flexible, and costs plummet. Early in World War II, each M1 carbine costs about $45 to manufacture, half the price of an M1 Garand and 1/5 the cost of a Thompson submachine gun. By the end of the war, peak efficiency drives the cost down even further. Mid-1942, a young American paratrooper, a private in the 101st Airborne, stands on an English airfield awaiting his first combat jump. He's been issued an M1 carbine. He's unimpressed. It feels too light, lacking the weight and authority of the Garand carried by infantry riflemen. His sergeant says the carbine is meant for officers, radio men, support troops, not real fighters. The private wonders if he's been handed a toy. June 6, 1944, Normandy. The transport aircraft rattles through flak. The jump light flashes green. He steps into darkness over France, the carbine strapped to his leg. He hits hard, rolls, cuts free from his chute. The night explodes with gunfire. He can't find his unit. He's alone. Then he sees movement, German soldiers, maybe 50 yards away. He brings up the carbine. It's shorter than a Garand, quicker to handle. Safety off, sights up. He fires. The carbine cracks, cycles, fires again. 15 rounds without reloading. The enemy scatters. He survives. And in that moment, his view of the M1 carbine changes forever. Scenes like this play out across every theater of the war. Tank crews favor the carbine because it fits inside the cramped hull of a Sherman, and if you have to escape a burning tank, you want a weapon you can swing fast. Forward artillery observers carry carbines while calling in fire missions. Combat engineers move with carbines slung as they clear obstacles. Mortar crews fend off infiltrators with carbines when their heavy weapons can't be used. The carbine isn't built for long-range firefights at 300 yards. It's built for the instant when support soldiers suddenly become front-line fighters, and in that role it performs exceptionally. Still, criticism follows. Some troops complain about limited stopping power, especially in the Pacific, where Japanese soldiers wear thick quilted uniforms, or in Europe's winter, where heavy coats soak up energy. Beyond roughly 150 yards, the .30 caliber carbine round loses effectiveness. Bullet drop increases, penetration decreases. Infantrymen who trade their Garands for carbines sometimes regret it, usually after their first serious firefight.
The M1 carbine excels at the job it was built to do, but it was never meant to be a full-power battle rifle. Still, the scale of its production is almost impossible to grasp. From 1941 to 1945, American industry churns out more than 6.1 million M1 carbines. That's more than the M1 Garand, more than the Thompson, and more than any other small arm in U.S. military history. General Motors' Inland Division alone produces roughly 2.6 million rifles. Winchester contributes around 830,000. IBM, yes, the future computer giant, manufactures carbines. Jukeboxes stop rolling off Rockola assembly lines and are replaced with rifles instead. Production is relentless. Factories run 3 shifts around the clock. As men are drafted into the armed forces, women step in to take their places. Rosie the Riveter becomes Rosie the Gunsmith. Inspectors work non-stop, checking headspace, testing gas systems, and function firing every rifle. Defective parts are rejected, scrapped, and melted down. At peak output, thousands of carbines leave factories every single day. The logistics alone are staggering. Millions of wooden stocks, millions of barrels, bolts, magazines, and operating rods. Hundreds of subcontractors produce pins, springs, sights, sling swivels. The M1 carbine becomes a symbol of American industrial power, and soldiers keep requesting it. Even with mixed battlefield reviews, demand never fades. By 1944, the Army has enough carbines that most contracts are canceled. When Japan surrenders in September 1945, Winchester is one of only 2 companies still building them. The contracts end immediately. Workers are laid off, assembly lines shut down. More than 6 million carbines now exist, enough to equip U.S. support troops for generations. How the carbine performs in combat depends on who you ask. Speak to 10 veterans and you'll hear 10 different stories. A Marine radio operator on Tarawa praises the lightweight rifle that doesn't slow him down under heavy gear.
An infantryman in the Philippines curses it after watching enemy soldiers keep charging despite being hit. A tank commander in France swears by it, compact, fast, perfect for tight spaces. An army ranger in Italy gives his up after one fight and demands a Garand instead.
Then there's Audie Murphy, the most decorated American soldier of World War II. Murphy carries an M1 carbine during many of his actions in France. A Tennessee mountain native who learned to shoot hunting for food, he uses the carbine with deadly precision. He knocks out German machine gun crews, eliminates snipers, and during the action that earns him the Medal of Honor, Murphy holds off advancing German infantry with his carbine while directing artillery fire. When his ammunition runs out, he climbs onto a burning tank destroyer and fires its .50 caliber machine gun to keep fighting. Murphy proves an important point. In the hands of an exceptional marksman, the M1 carbine is deadly. But Murphy is the exception. Most soldiers are average shots, especially under stress. For them, the carbine's weaknesses are harder to ignore. Army evaluations in 1951 reveal that 95% of effective carbine fire occurs at distances under 50 yards. Beyond that, hit probability drops sharply. Complaints focus on stopping power. The carbine's 110-grain bullet, compared to the Garand's 174-grain round, delivers less energy. In many cases, multiple hits are required to stop an enemy. The winter of 1944 makes things worse. During the Battle of the Bulge, American troops fight in freezing temperatures, bundled in heavy coats. German soldiers wear even thicker winter uniforms. Carbine rounds sometimes fail to penetrate enough layers of clothing to reach vital organs. Some soldiers carrying carbines request Garands instead. Others keep their carbines but compensate by carrying extra magazines, trading power for volume of fire. In December 1944, the Ordnance Department approves the M2 carbine, a select fire version capable of fully automatic fire at roughly 750 rounds per minute. Conversion kits allow armorers to upgrade existing M1 carbines to M2 configuration. The M2 addresses stopping power concerns by enabling rapid, repeated hits. But the war ends before large numbers reach frontline units. Only a small number see combat during the final Allied push into Germany. And here's the irony. The Germans love the M1 carbine. Captured examples are highly valued by Wehrmacht and SS troops. The German military officially designates it the Selbstlade Karabiner 455A, a self-loading carbine of American origin. Photographs from the Battle of the Bulge show German paratroopers and SS soldiers carrying M1 carbines alongside their standard-issue weapons.
Photographs from December 1944 showed German troops near Poteau, Belgium, armed with captured American carbines. Even the Volkssturm, Hitler's last-ditch militia of elderly men and teenage boys defending Berlin in 1945, uses seized M1 carbines. They're far more effective than the outdated rifles and shotguns these units are normally issued. Why did German soldiers favor the American carbine? For the same reason U.S. support troops needed it in the first place: mobility. Retreating forces don't have the luxury of time or training for heavy weapons. A captured M1 carbine is light, simple, semi-automatic, and intuitive. Load a magazine, pull the trigger. No specialized instruction required. Its simplicity, its greatest strength, makes it universally usable. In doing so, the M1 carbine accomplishes something extraordinary. It reshapes American military doctrine. Before its introduction, support troops were typically armed with pistols or not armed at all. They were expected to withdraw if attacked. The carbine changes that equation. Radio operators can return fire. Truck drivers can fight back during ambushes. Medics can defend wounded soldiers. The line between combat troops and support personnel begins to blur. The consequences are significant.
U.S. logistics units become far harder to attack. Enemy forces that once preyed on lightly defended supply columns now face armed resistance. With carbines widely distributed, American units maintain local security without pulling riflemen away from the front. Every soldier is armed. Every soldier is a threat. The psychological impact is just as important. Support troops gain confidence knowing they're not helpless. Morale improves. Being trusted with a real firearm, not just a sidearm, matters. A soldier who believes he can defend himself performs better under pressure. That belief can be as decisive as raw firepower. There's also an economic angle. By the end of the war, each M1 carbine costs just $32 to produce. For the price of equipping a few thousand soldiers with Thompson submachine guns, the Army can arm millions with carbines. The savings help fund tanks, aircraft, and artillery. The carbine becomes a cornerstone of America's industrial victory, winning through efficiency and mass production. When World War II ends, planners assume the M1 carbine will quietly fade away. They're wrong.
In 1950, the Korean War erupts, and the carbine returns to combat, this time largely in its M2 select fire form. U.S. and South Korean forces rely heavily on it, but Korea exposes its limits. North Korean and Chinese troops wear thick padded winter uniforms and launch massive human wave assaults. Soldiers firing M2s on full automatic burn through magazines in seconds, sometimes running dry as enemy troops close in. Official reports note a pattern. Inexperienced soldiers waste ammunition by relying too heavily on automatic fire instead of aimed semi-automatic shots. Veteran troops adapt. They use automatic fire only in emergencies, saving semi-auto for accuracy and control. The carbine continues its long service life in Vietnam from 1965 to 1975. Special Forces advisors carry carbines while training Montagnard tribesmen. Helicopter crews keep them close at hand. South Vietnamese forces receive thousands from American stockpiles. Even as the M16 enters service, carbines remain in circulation, reliable, familiar, and abundant. Officially, the M1 carbine leaves U.S. military service in the mid-1960s. Unofficially, it lingers for decades. Some National Guard units retain carbines into the 1980s. Foreign armies and police forces around the world continue using American surplus well into the 21st century. Taliban fighters in Afghanistan are photographed carrying M1 carbines as late as the 2010s, more than 70 years after the weapon's introduction. Today, wartime carbines are prized by collectors. An original Winchester or Inland model in good condition sells for $1,500 to $2,000. Scarcer manufacturers like Rockola or IBM command even higher prices. Modern reproductions from Auto Ordnance retail around $1,200. The design itself is public domain. Anyone can manufacture an M1 carbine, and many do. In the end, the M1 carbine represents both the strengths and compromises of wartime weapon development. By rifle standards, it's underpowered. Its effective range is limited. Stopping power is inconsistent. Frontline infantry often disliked it. But it was never built for frontline infantry. It was built for the radio operator hauling equipment, the tank commander escaping a burning vehicle, the artilleryman defending his gun, the combat engineer clearing obstacles under fire. For those soldiers, the carbine was nearly ideal. The numbers say it all. Over 6 million produced, more than any other American small arm, serving across 4 major wars and adopted by dozens of nations.
Somewhere in the world, the M1 carbine is still in use today, more than 83 years after it was officially adopted. Not bad for a weapon created by a convicted killer, assembled in just 13 days, and mass-produced by companies better known for jukeboxes and office machines. One American test pilot who flew bombing missions over Germany later recalled carrying an M1 carbine as his personal weapon. He once said, "I never loved that rifle. It wasn't powerful enough for my liking, but every time I slung it over my shoulder, I knew it would function." And that's all a soldier truly needs, something that works when everything else goes wrong. The M1 carbine did exactly that for millions of American servicemen across 3 decades of conflict. It worked. A $45 rifle, designed in under 2 weeks, went on to outproduce, outlast, and outserve weapons that cost several times more and took years to perfect. Because sometimes the best weapon isn't the strongest or the most advanced. Sometimes it's simply the one that keeps functioning when it matters most. If this deep dive into American wartime innovation and the overlooked weapon that armed millions captured your interest, hit the like button and subscribe. We explore the untold stories of courage, engineering, and the moments that shaped history. The next chapter of World War II is coming. You won't want to miss it.